All right, let's talk about how to go about dealing with the gas law problem. So first of all, we have to consider what it's asking for and what we need to calculate. So we look at the question and we see that we've got volume and pressure. And pressure is changing, volume is changing. So when pressure and volume are changing, we need to find something that involves pressure and volume, and this law does just fine. Happens to be called Boyle's law, but that doesn't matter. Just if you didn't have access to this equation, this is what does it. So if that's what's going to be the law that we need to identify what the variables are so we figure out what we're solving for. So, is this V1 or V2? Let's see. Read the question. If the pressure in the gas is decreased from this to this, so if it's decreased from that to that, then this must be the pressure we started with, and this must be the pressure we ended with. New volume must be V2, which means this must be, by process of elimination, V1. If that's the case, then what we have here then is a need to solve for V2. So solve for V2. Divide both sides by P2. So V2 equals P1 V1 over P2. Now we plug in the numbers. Pressure 1 is this, 849 millimeters of mercury, times V1, which is 5.54 liters. And on the bottom is P2, 456 millimeters of mercury. And that leaves you type that in the calculator and you get an answer. Let's see, 849 times 5.54 divided by 456. That gives that answer. And with 3 sig figs, 3 sig figs, 3 sig figs, we'll have 3 significant figures in the answer, 10.3. And millimeters cancel millimeters of mercury, so that leaves liters as the unit. So that's the new volume, 10.3 liters. Okay, let's skip ahead to a different sort of question. 13.3a, because these other ones would be pretty similar to what I just did. All right, temperature of a gas in a container is decreased, so we got something changing. So temperature changes, original volume, so volume changes, temperature and volume. Okay. Okay. Original volume, original means like number 1, so that's V1, which means this must be V2. Decrease from this to this, so this must be temperature 1, this must be temperature 2. So temperature and volume, we got to think back, this equation, V1 over T1 equals V2 over T2, will do the job. It's called Charles' law, not that that's important, but this is what we need in order to process these variables. And we're solving for V1, which is this right here. So that's an easy matter. Just simply times both sides by T1. And when you multiply both sides by T1, you're going to get V1 equals V2 T1 over T2. Great, except before we do that, we cannot plug these numbers in here. Remember, never use degrees Celsius for solving these questions. It has to be Kelvin. So 49 degrees Celsius. Degrees Celsius is always smaller than Kelvin, so that's how now I'm going to add to turn this into Kelvin. The Kelvin number is always bigger. Now it turns out when you do the math, this is 322 Kelvin, this is 263 Kelvin, and then you plug the numbers in. So volume 2, right there, 8.9 liters, times temperature 1 was 49 degrees Celsius, so that's 322 Kelvin. Bottom, temperature 2, negative 10 degrees Celsius comes out to 263 Kelvin. If you do the math, it comes out to something like 10.89657795, blah, blah, blah. We're going to round that to, let's see, 2 significant figures. We ignore temperatures. We do not count them for significant figures, so we just look at the sig figs for non-temperature numbers for reasons that it's complicated, but it turns out lots of weird things can happen here. So ignore temperatures when it comes to sig figs. Anyway, that gives an answer of 2 sig figs, so 2 sig figs here. That 0 is next to an 8, so it rounds up to make 11 liters is the answer, is the volume 2, or rather the original volume. And which makes sense. it got colder, which means it shrank from this volume to this volume. Okay, that's that. Let's do the third type of question on here, because this is just like what I just did, and so is this one, on therefore to 13-4. Okay, so what do we have here? We got temperature and pressure. The one equation that satisfies that is P1 over T1 equals P2 over T2. That is Guy-Lussac's law. All right, anyway, let's see. Let's identify what's going on. Decrease from this to this, which means this is temperature 1, this is temperature 2. What it decreases to is what it becomes in the end, which is number 2. Let's see. At its new temperature, it exerts a pressure of 540 torr. What was the original pressure? So at a new temperature, this is the pressure. That's how I know it's P2. Original pressure, that alone tells me it's P1. Even if this was difficult to understand, original pressure means P1, which means by process of elimination, this must be P2. All right, well, let's do it again. Arrange for P1, so that will do. Let's multiply both sides by T1. So that cancels. P1 equals P2 T1 over T2. We need to figure out temperature in Kelvin, not degrees Celsius, so 34 degrees Celsius plus 273. And then negative 20 degrees Celsius plus 273 equals a temperature that comes out to, let's see what I calculate as, 307 Kelvin, and this is 253 Kelvin. All right, so given that, we can then do our calculations. So then pressure 2, 514 torr. Temperature 1 was 34 Celsius, which is 307 Kelvin. And then temperature 2, negative 20 degrees Celsius, makes 253 Kelvin. Do the math. It comes out to about Kelvin cancel Kelvin to give torr for your answer, so it's about 623.7075 blah 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 torr, which means we need to round to, let's see, ignore these for sig figs, so we just look at the non-temperature numbers. 514 torr gives an answer of 514, or well, 3 sig figs, so 3 sig figs here, this 3 is next to a 7, so it rounds up. That's 624 torr becomes the answer. All right, so these other ones, similar sort of process what you want to undertake. You may be solving for different variables in there. Just pay close attention to what's your P1, V1, P2, T2, V1, V2, etc. All right, that should be a nice little overview of all the different types of calculations for introductory gas law practice.